Hey guys, welcome to my channel Cloud Tech Services. A very important part of working in IT is creating lab environments for testing out various scenarios before getting those solutions implemented in the production environments. A lab environment is basically a small replica or prototype of a larger organization's environment. The most fundamental basis of creating this lab environment is a virtual machine. Previously in my channel, I have discussed about Azure virtual machines and nested virtualizations. In today's video, we would look into virtualization in a bit more detail and then learn how to create a Hyper-V virtual machine on a physical device. So let's get started. Before starting to create the Hyper-V virtual machine on any physical device, let's first understand the concepts of virtualization and how we can create a VM in a physical server. Let's start with the basics of virtualization. Virtualization is a technology which helps to create a replica of any physical hardware on a software. It allows users to run multiple operating systems or multiple applications simultaneously on a single computer. Virtualization is the process of creating virtual versions of physical computing resources, such as servers, storage, and networks. These virtual resources are created on a software layer, which is generally known as the hypervisor. This slide contains an image which shows the architectural representation of a hypervisor. The hypervisor acts as a middle layer between the hardware layer and the guest machines or the operating systems. The hardware layer contains physical devices, which has a processor with virtualization extensions. These virtualization extensions that sit on the CPU enables the hypervisor to use the same processor for running guest operating systems and applications. These extensions basically create a virtual CPU within the physical CPU, and this virtual CPU is then used by the virtual machines. The hypervisor allows both the host operating system and the guest operating system to run together. The virtualization not only happens for servers, but it can also be achieved for other components as well. The different types of virtualizations can be understood as follows. The first and the most common type of virtualization is server virtualization. When using server virtualization, it allows users to divide one physical machine server into multiple isolated virtual machines. These isolated virtual machines utilize the resources of the physical machine, such as its RAM, memory, and network. The second most widely used virtualization is storage virtualization. This abstracts physical storage from multiple network devices into a single centralized logical pool. Storage virtualization simplifies management, improves capacity utilization through thin provisioning, and allows for flexible data migration across heterogeneous hardware, reducing costs and downtime. Another very popular method of virtualization is called as the network virtualization. This abstracts network resources such as switches and routers from physical hardware into software, creating independent virtual networks on a shared infrastructure. Network virtualization improves flexibility, security, and efficiency by enabling automated, software-based control rather than manual, hardware-driven configurations. Some very common examples of network virtualizations include virtual LANs for segmentation, overlay networks, virtual private network or VPN used for secure remote access. Another type of virtualization is the desktop virtualization. This is a technology that separates a desktop operating system and its application from the physical client device. This allows users to access a virtualized centralized desktop environment from any location or device. Improved data security, simplified IT management, lower hardware costs, and its support for remote work are some of the key benefits for desktop virtualization. Some popular examples of desktop virtualizations can include Citrix, VMware Horizon, Microsoft AVD, Windows 365 technology, etc. The last one on this list is an application virtualization. This separates the software from the underlying operating system and allows programs to run into isolated encapsulated environment without any traditional installation. This type of virtualization enhances security, eliminates conflicts between applications, and enables faster deployment and streaming. Some of the most common examples of application virtualization include AppV and containers. Some of the key benefits of using virtualization includes reduced hardware cost, better resource utilization, scalability and flexibility, isolation and security, and disaster recovery. Virtualization allows us to use hardware efficiently, and the virtual machines or the other resources required can be created in minutes. The virtual machines that are created, they do not affect or get affected by the host machines. If a virtual machine crashes, it does not affect the other virtual machines or the host machine that it is running on. And virtualization also allows us to capture live migrations, snapshots, and backup integrations, which allows a huge flexibility in disaster recovery. The virtualization software that we are about to look into is the Microsoft Hyper-V. Microsoft Hyper-V is a Microsoft Type 1 hypervisor, which allows us to create and manage virtual machines on Windows servers and Windows Pro, Enterprise, and Education editions. There are, in general, two types of hypervisor. Type 1 hypervisor directly runs on a bare metal hardware. Some of the examples of a Type 1 hypervisor includes Microsoft Hyper-V and the VMware ESXi. The Type 2 hypervisor runs on top of an operating system. A Type 2 hypervisor is basically installed as an additional software on an existing running operating system. Some of the examples of Type 2 hypervisor includes a VirtualBox and VMware workstations, etc. From this image right here, you can see that the virtualization enabled hardware sits as the first layer upon which our Windows hypervisor is installed. And once the Windows hypervisor comes into picture, it allows us to run several applications, several other servers at the same time, side by side, on the same virtualization enabled host machine or the hardware. There are some basic prerequisites required on a hardware level for the Hyper-V to run. The Microsoft Hyper-V supports 64-bit processor with SLAT and CPU support for VM monitor mode extensions. The virtualization support must be enabled on the UEFI or the BIOS of the host machine. It is recommended that the host machine has at least a minimum of 4 gigs of RAM, but for smooth running of multiple virtual machines, it is suggested or it is recommended to have significantly large amount of RAM attached to the physical machine. Hardware enforced data execution prevention must also be available, and it should be enabled on the host machine. Additionally, the host machine should be running on Windows 10 or 11 Pro, Enterprise, or Education for single session virtual machine access, and Windows Server 2012 or any later edition for multi-session virtual machine access. For higher input-output performance, the storage drives attached to the physical machine is recommended to be either SSDs or NVMEs. Some of the Hyper-V features include enhanced security and isolation by using virtual TPM and secure boot, high availability and continuity due to the presence of live migration and facilities of creating failover clustering and Hyper-V replicas, Performance and scalability, showing dynamic memory and large-scale support. Networking and storage functionalities, such as creating Hyper-V virtual switches and having discrete device assignments or DDAs. Nested virtualizations and checkpoints help in management and development of multiple virtual machines on the same physical host. And the different Hyper-V versions available for different operating systems, such as for Windows servers and Windows 10 or 11 Pro Enterprise and Education. With this, let's start to look into the demo for creating a virtual machine on a Hyper-V device. To create a virtual machine in Hyper-V, the first step is to enable the Hyper-V features. To do so, open the search option present in the taskbar and search to turn on the Windows features on and off. On this window, click this to open up. Now on this window, we can see the option that's available mentioned as Hyper-V. Enable or check this option. Make sure both the Hyper-V management tools and the Hyper-V platform is also selected or included, and then click on OK. As soon as we click on OK, it will start looking for the required files that are needed to enable the Hyper-V. And once those files are installed, the system will ask for a restart. So let's wait for the system to get those files downloaded or installed for us. Now that we can see that it has applied all the settings and it's asking us to restart. So let's restart the system now and come back to see how the Hyper-V looks like. Now that my system has restarted, let us now see if Hyper-V has been installed successfully. To check this, I'll click on the search option and type in Hyper-V. It might take some time to look for the Hyper-V, but the option should show up. So let's give it some time. Upon clicking the Hyper-V option, the Hyper-V console opens up. On this console, this is the name of my system, that is the Hyper-V host right now, and this is the console where the virtual machines would be created. Creating a virtual machine in Hyper-V is very similar to creating a virtual machine inside of an Azure host machine. I will tag the video link in the video description. Do check that out. If you like the content, do like and share, and subscribe to my channel for more such videos. Please leave a comment on what other topics you guys want me to cover next. Thanks for watching.